For this problem, we're going to be solving an equation involving rational expressions. So to start this off, we have 4x over x plus 2 plus 2 over x minus 1 equals 4. Whenever you have an equation involving rational expressions or fractions with variables, then your first step is to take every denominator and set it equal to 0. This will tell you what values will cause your denominator to equal 0, and therefore if you get those as final answers, then you would have no solution, as you cannot have division by 0. So we're going to take both of our denominators in this case, x plus 2 and x minus 1, and we're going to say that each of these cannot equal 0. And then we're going to solve for x alone to see what value causes each of these to equal 0. So in the first case, we'll subtract 2 from each side to get x cannot equal negative 2. And then in the second case, we're going to add 1 to each side to get x cannot equal positive 1. If either of these is our answer at the end, then there is no solution. So, moving back here, in order to start solving an equation of this form, our first step is to find the least common denominator, or the LCD. If we find this LCD, we can multiply it to every single term, which will make it where we have not changed the problem, but it will rid us of all of our fractions. So, the first thing we want to do is look at our first denominator and second denominator and see if they are factored. In this case, they are both completely factored, so we can start checking each of them for unique factors. In the first case, we have x plus 2. So we're going to jot it down as our first factor of our LCD. And now we're going to check, do we have any other unique factors? When I say unique, I mean if this were x minus 1 times x plus 2, then we wouldn't need to count that x plus 2 again, as it's already taken care of in our factors of our LCD. We've already jotted it down once. If it were an x plus 2 squared, then we would have to count a second one in our LCD like so, because the second x plus 2 is unique. The first one is not. Okay, so going back to the original problem, we just have an x minus 1. That is unique. We haven't written down an x minus 1 yet, so we'll copy that down as another factor of our LCD. Now 4 has no denominator, so this is our complete LCD, x plus 2 times x minus 1. So from here, we can now take this LCD and multiply it to every term on each side of the equal sign that's being added or subtracted. This will not change our problem, and it's going to get rid of our fractions. So, I'm going to write this out the long way. Rather than just show this term multiplied to each of these, I'll rewrite the entire problem to avoid any confusion. So this is going to be multiplied to 4x over x plus 2. And then we're going to add that to, again, x plus 2 times x minus 1 times 2 over x minus 1. And that's all equal to 4 times x plus 2 times x minus 1. And now we want to check what values we can cancel. So when I say cancel, notice that here we are technically multiplying two fractions together. this x plus 2 times x minus 1 is technically over 1 in both cases when we're multiplying it to a fraction. We don't need to do that in the third case, as 4 is not a fraction, so that wouldn't help us simplify this. So from here, this x plus 2 is in the numerator, and it's being multiplied to a fraction with x plus 2 in the denominator, so we know that we can cancel those factors out. Likewise, over here, the x minus 1 is in the numerator and denominator, so those will cancel out, leaving us with x minus 1 times 4x plus x plus 2 times 2. And that's all equal to 4 times x plus 2 times x minus 1. Now that we have this, this is just a standard algebraic equation that we can start multiplying out and solving for x. So we'll distribute this 4x to each term. Since we're multiplying and we have subtraction, we have to distribute. So that gives us 4x times x is 4x squared. 4x times negative 1 is minus 4x. Plus, now we have to distribute the 2 to each term. 2x plus 4. And now finally that's equal to 4 times x plus 2 times x minus 1. I'm going to multiply out the x plus 2 times x minus 1 first and then distribute the 4. So I'll do 4 times the quantity of, and we have to distribute this x to each term and then distribute the 2, which gives us x squared minus x. And then distribute the 2, that gives us 2x minus 2. And now we just start combining our like terms. We have 4x squared. And then this negative 4x plus 2x becomes minus 2x plus 4 equals, here we're going to add our like terms together and then distribute the 4. We have 4 times x squared, negative x plus 2x becomes plus x minus 2. And now we can distribute the 4. So we end up with 4x squared minus 2x plus 4 equals 4x squared plus 4x minus 8. Now we want to start combining our like terms all on one side, getting our x alone. So the first thing I'm going to do is get rid of this 4x squared that's on each side by subtracting each side by 4x squared. When we do that, each of these will cancel out. And now we're left with negative 2x plus 4 equals 4x minus 8. From here, I want to move the smaller x to the other side, so we want to add this 2x to each side, which gives us 4 equals 6x minus 8. And now to get the x alone, I will add 8 to each side, which gives us 6x equals 12. And finally, dividing each side by 6 to get the x alone, we are left with x equals 2. And before we circle this and say it's our final answer, remember we have to go back up to where we started at the beginning, We had to check what values would cause division by 0. Those values were -2 and +1. This answer is +2, which means it will work. It's not one of our bad values. So x equals 2 is the solution to the original problem.